Hello everyone, this lecture video is all about pressure, and before we define the term pressure, let us have here the two scenarios, 1 and 2. So as you can see the scenarios here, there's a person hammering a nail on the wall, but the difference here on the first scenario here, the pointed part of the nail is pierced on the wall while being hammered, while on the second scenario, the flattened surface of the nail is the one being pierced in the wall or being hammered. So when you hammer an iron nail, you apply force on the flat side of the nail since you are hammering on this part of the nail, and then the pointed side of the nail, therefore this one which is in the contact with the wall, this is the one that applies force on the wall and tries to pierce the wall. But what will happen if you have, or if you hammer the flat side of the nail or the circular part here on the wall, and then you will have trouble in piercing the wall with the flat side. So even though you increase the force or double the force compared to the first scenario, why is that? The reason of that is pressure. The pressure here on the first scenario is greater compared to the second scenario. We have here a lesser pressure because as you can see here, the area in contact is less if you will enlarge the nail. So if you will pierce this one in the wall, this part, the pressure will be greater, and the area in contact is less because the area in contact is less. And then on the side, if you will hammer this on the wall, such as on the second scenario, the pressure is lesser compared to the first scenario because the area in contact is more or greater than the first scenario. So why is that? From here, we can define pressure as a force per unit area. It is a force per unit area in which the units, we can say, force is Newton and the area is meter squared. And in SI unit, when you perform this operation, the unit will be in Pascal. So the unit for pressure is in Pascal. So why this is important? I have mentioned if you pierce this part on the wall, there is a greater pressure because the area in contact is lesser. And if you hammer this part, the pressure will be lesser because the area in contact is greater, this one. So why is that? If you will look on the formula here, so let us try. So let's say I will keep the force in constant compared, and I will just increase the area. Okay, just like what happened on the nail, we just switch the parts of the nail to switch the size of the area. So I have here 3 Newton as the force and then 5 meters squared as the area. If you will divide that, you will have 0.6 Pascal. And let us increase the area and keep the force constant. So let us add 1 here. Let us say, so that will be 3 Newton divided by 6 meters squared. That will be 0.5 Pascal. And then another example, let us increase the area again, 3 Newton over 7 meters squared, that will be 0.4 Pascal. And then another one, 3 Newton divided by 8 meters squared, that will be 0.38 Pascal. So as you can see here from this example, keeping the force constant and just increasing the area, the Pascal or the unit of pressure or the value of pressure decreases. It decreases as the area increases. Okay, so that's what happened here in the scenario 1 and 2. That is why the pressure is greater because the area in contact is lesser. And the scenario 2, there is a lesser pressure because the area in contact is greater than the scenario 1. And therefore, if there is a lesser pressure, such as this one, the work is harder to do compared to the first one. This, you can easily pierce the wall here with the nail because again the pressure is greater and the work here is harder to do compared to the first one. And what else? So the name Pascal as a unit PA is named after the French mathematician and physicist Blaise Pascal in honor with his works and contribution in physics. And then let us proceed here another applications of pressure in our daily lives. For example, I have here a kitchen knife cutting on an apple fruit. So the reason why we are using the sharper part because it has a lesser area compared to the blunt edge. So this is the nail and you have two main parts here. We have here the cutting edge and the blunt edge, and if you will enlarge that, it is thinner and therefore has a lesser area compared to the blunt edge. So that is why it is easier to cut a fruit or a vegetable or any food using the cutting edge because that is thinner and therefore has a lesser area, and therefore it will have a greater pressure and will do more work or force on the object. So next I have here a drilling machine which has a pointed part which makes having a greater pressure and will do the work easier. And another example is a syringe needle. So let's say you want to inject a substance on a person. Let's say that is a vaccine. You have your hand, for example, and then you have here a pointed needle. So if you will enlarge this one, your finger has a large area. So since it has a large area, there will be a small pressure and therefore the work of injection is harder. So, but if you will use a syringe here, which has a small area, it will have a large pressure and the force to do that will be easier. Okay, so you are using this type of syringe, the smaller needles, or what we call the hypodermic needles, to rapidly inject a substance on a person's body. Let us proceed on the pressures and liquids. Yes, pressure. Liquids also exert pressure. So, as you all know, the gravity on our Earth is in downward. So, if you have, let's say, a bottled water, the direction of the surge of the pressure is downward because the force of gravity is downward as well. So, let us divide this bottled water into 5 parts. 1, 2, 3, 4. 1, 2, 3, 4, 5. So that is 5 parts. And let us say you have a needle or a pin, pointed pin, and you will try to punch a hole on this part. Okay. So let us say you poke a hole here or punch a hole here. So the flow of water here will not roll in the bottled water. It will create a perpendicular angle, or it will create an angular flow. So the flow of the water here is like this. Again, let us use another color. For that, let us use blue. Okay, the flow of the water is angular. It will not roll on the sides of the bottled water. Okay, let me draw. So that is the flow of the water. So let us say you punch a hole on the second part here. That is 1, that is 2. So the angular flow of the water here is greater compared to the first part that you have punched a hole for. And then let us have here punch a hole on the third part. So the flow of the waters has a great angular flow compared to the 1 and 2. And if you will punch a hole on the fourth part, it will have again a greater angular compared. And if you will punch a hole on the fifth part of the bottle, it will have a greater angular flow compared to the 1, 2, 3, and 4 parts. So the point of this is the upper parts of the bottle here has a lesser pressure, and the bottom part of the bottle, let us say 3, 4, 5, or just 4 and 5, it has a greater pressure compared to the upper part of the bottle. Why? Because again, the flow of the pressure is downward because of the gravity. It is downward. And that is why the construction of dams here, since the water has a high pressure at the bottom and the low pressure at the upper part of the water, the construction of the dam is thicker. It has a thicker wall on the bottom and thinner wall on the upper part of the dam to avoid the collapse of the dam and damage to many lives. The construction is designed to have a thicker wall in response to the higher pressure of the water. So I have here some examples of the dams. We have here, you can see flowing waters on the dams. So we call that as spill gates or flood gates. Okay, they are opening that just in case there is too much water. Let's say there is a typhoon and then the dam is filled with water. So to avoid the collapse of the dam because it cannot hold too much water beyond its limit, they are opening the floodgates of the dam. Just like what happened in the Magat Dam in Bulacan. Okay, they opened 3 gates there and that is enough to flood the area. But if they did not do that, the whole dam will collapse and therefore it will endanger more lives in Metro Manila until Mindanao. So opening the gates is safer compared if you will just let the water flow out on the dam and the dam will collapse. There will be a high sea level afterwards. Okay, so here are examples of the floodgates of the dam. Okay, another example. Now, okay, as that analogy, the water bottle has also its limit, meaning therefore you cannot fill it beyond its limit. That if you fill the bottled water more than its limit, it will flow out, just like the dams as well. And now let us proceed on the pressures in atmosphere or pressures in air. First, pressure decreases as altitude increases. Let us have here the layers of the atmosphere. I have here the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. We are not doing earth science here, so I won't elaborate on that part. Let us do some physics. As I have mentioned, pressure is equivalent to force over area. Why am I using red? Let us use another color. Let us use green. So, as you can see here, the universe from the Earth expands wider, and therefore, the area here is greater as you go above the Earth atmosphere. But the force of the Earth remains the same, the gravitational force, which is 9.8 meters per second. Therefore, the pressure will decrease as the altitude in the atmosphere increase. So, the pressure, this is the pressure, will decrease as the altitude increases because the area again here increases as you go higher in the universe, wider, okay, farther in the atmosphere, and the force that holds that atmosphere is constant, 9.8 meters per second squared, and therefore the pressure on that part is lesser. And what will happen on that? So one of the scenarios that will happen if the pressure decreases as altitude increases is that the boiling point of any liquid decreases as pressure decreases as well. So meaning to say, if the boiling point of water is 100 degrees Celsius, the boiling point varies as you go in higher altitudes. The boiling point of water versus the elevation. So at sea level, that is 100 degrees Celsius. That is why you have the hot spring near the volcanic vents. There is a 100 degrees Celsius there in contact with the magma. Okay. But as you go higher in elevation, you see here 200 meters above sea level up to 10,000, the boiling point decreases. We have here from 100 degrees Celsius. The water may boil at 70 degrees Celsius when it has a increased elevation. So let us say, for example, the world highest mountain, the water will boil at 69.94 degrees Celsius. Then highest freestanding mountain, let's say the water will boil at 80.33 degrees Celsius. So if you will see the elevation value, this one is higher compared to this one, and the boiling point is 69.94 here because the elevation here is higher compared to this one. Okay, the lower the elevation, the higher the boiling point. And as the pressure decreases due to the altitude, the boiling point as well decreases. So you can have a boiling water at 32 degrees Celsius depending on the altitude. And then as for the freezing point noticeably increases as altitude decreases or as the pressure decreases. You cannot notice it at all. There is a slight change, but the freezing point increases as you go higher in altitude or as the pressure decreases. So let us discuss more on the pressure, air pressure at sea level and above sea level. At sea level, you have here a higher air pressure compared to the above sea level. Let's say on a mountain, you have here a lower air pressure. So if you will have a stats here, I have here a graph of the elevation above sea level from negative 2,000 to the 0 up to the 14,000 elevation. And here is the pressure. The pressure decreases as you go up above the sea level. So this is the pressure, it decreases as you go above the sea level. So meaning to say, for example, the impact of altitude on oxygen levels. So we have here a high amount of oxygen on lower or oxygen pressure on sea level compared to higher pressure. So let us say the partial pressure of oxygen at sea level is 159 millimeter mercury. This is a unit. The millimeter mercury is another unit for pressure. And when you are at Mount Everest, at least 8,848 above sea level, the partial pressure of oxygen there is 53 millimeter mercury. That is why the oxygen moves freely apart each other. They move freely apart, the density of that, because the force here is lesser. The kinetic molecular force is lesser compared to the sea level. Why is that? Because again, you go greater, you go higher in the altitude, there is a radiation that breaks the bond of the molecules. There will be no cohesion, no adhesion, no kinetic molecular force that will bind the molecules of the water. Therefore, the molecules moves freely compared to the sea level. So that is the reason, another reason. And then what else? So that is all for the basic concepts of pressure in solid, liquid, gas.